introduce you to a father and son astronomy loving duo. This is George and Eric White. They're going to wow us with astronomy, telescopes, and super cool space stuff. George and Eric, take it away.
Well, good morning, everybody, and welcome. So I hear we are worldwide. I hear we got some folks down in South Africa. I know down in Australia, I think we've got possibly two little girls down there around Adelaide somewhere, Mabel and Elka. Wanted to say hi. And I think we might have Finn out in Chicago if he's dialed in yet. So this was fun for us. So we are here in Colorado Springs, Colorado, and we are with the Colorado Springs Astronomical Society. Basically, it's about 150 people who get together and we do astronomy. We go out to all the schools and the parks and we present the skies to everybody so that they can have a chance to see things that they might not otherwise see. So Eric's been doing it. How long have you been doing astronomy?
Since I was 4. I started in Germany when I got my first telescope, which I'll actually show you later. And because we live so far out in the country, there weren't any big bright lights around. We were able to see even with that little telescope, Jupiter and its moons. And later I plan on teaching you how to do that as well. But I've been into astronomy ever since then. I moved here a while ago and I learned about the Colorado Springs Astronomical Society in 3rd grade, actually, for a project I was doing. And I've been observing with them ever since. We do outreach events a bunch. I love volunteering at those. Now, since we can't do those, of course, this is a fun way to do it instead.
And, I've been doing it myself since I was a kid. So when I was a boy, my mom got me one of those little silver telescopes like you can get at the toy store. And with that, I used to go out in my backyard in Massachusetts. And in the wintertime, I would build igloos out of snow. And then I would take the roofs off and those would be my observatories. And I would sit out there in the snow in the freezing cold in the middle of the winter. And I would observe the stars as best as I could. The hard part was that I didn't know what things were. So I would get out there with my telescope. You know what? How many of you have telescopes? Raise your hands if you've got telescopes. There's a few. Okay, so the hard part about it, I think, is that when you're looking up in the sky, of course you can see the moon, right? The moon's right there and it's right and big and you can look at it with your telescope. It looks really cool. Okay, but the hard part is all those other little points of light, because if you don't know what they are, you don't know what you're looking at. Now, if you're trying to see things like you see on the Hubble Space Telescope with all the all the pictures and the colors, and it looks wonderful and fantastic, and you can't see anything because they're just little points of light and you don't know what you're looking at. So that's where getting involved with things like your local astronomy clubs comes in, because they can help to teach you where everything up in the sky is and how to find them. And we're going to talk about that a little bit later. So what we're going to talk about today, first, we're going to go over a little bit about the history of astronomy, how it came about. Okay, we're going to talk about a couple of the people that were involved in bringing astronomy to the world, who are responsible for the telescopes that you have in your living rooms. Okay, we're going to ask a lot of questions. Well, maybe not a lot of questions. We'll ask some questions. And you guys are going to get to answer them. And then we're going to show you a bunch of telescopes that we've got. And Eric's going to explain a little bit about how they work. And then after that, we're going to take you on a little tour of the solar system. And then if we have some time left over, we'll show you some cool stuff that we got lying around. Okay. So first up, or maybe not first up, if my slide won't go. Stand by. And, well, we did everything except make the slides go. There we go. There's your technical glitch, Janet, right there.
I know, there's always one or several.
Of course. Okay, so basically, thousands and thousands and thousands of years, of course, people looked at the skies, okay? What they didn't have cameras, they didn't have telescopes. What they had was their eyes. And everything that they interpreted, everything about how they lived in their world, they could see. So what they did here, 3,000 BC, 5,000 years ago, people wanted to know what time of the year to plant their crops. They wanted to know what time of the year to move their houses, to follow the herds of animals, okay? So they would build structures like this in Ireland. Now this structure they built so that at one certain time of the year, the sun would come down and the sun would go right in this door right here, and it would light up something inside. So it acted as a clock for them. Okay. Next one. So who knows what this is? Anybody know what this is? Janet, pick somebody raising a hand. Let's see if they recognize what it is.
All right, let's see. Anybody out there know? Anybody out there know? Let's see. I don't see any hands. Wait. Oh, Anders got a hand up. All right, Ander, what is it?
Stonehenge.
That's right. That's right. Stonehenge. So this is built in England, also between 3000 and 1600 BC. So between 5000 and 3500 years ago. Now there's a lot of ideas of what it might be. Okay, folks think that this may be someplace where people that were important were buried. But we do know that it was used as a clock. In something called archaeoastronomy, we study how ancient civilizations studied the skies and used the skies. And one of the things they did is they built clocks to observe where the sun set and where the light shined through at certain times of the year, the equinoxes. Okay, so when you see a building like this, and especially when you see it like this, you can see how the sun would shine through and light up certain stones at certain times of the year. So even though they didn't have calendars like we do, they certainly didn't have computers to look things up. By where the sun shined through certain doorways and lit up certain things, they could tell what time of the year it was, and they knew things that they had to do. They knew that it was time to plant the crops. It was time to grow the corn, because you have to start now, because 3 months from now, it's going to be time for the harvest. And then the sun and the moon would set along certain lines. They knew it was time for the harvest. So this is called archaeoastronomy. This is a disc that was found buried in Germany. It's about 3,500 years old. Okay? They call it I believe it's called the sky disk, the night disk. And what it shows, people think, is the crescent moon here on the side, right here. Okay, this is either the sun or a full moon, the stars in the sky where they sit at certain times of the year, and then other markings, and people would use this to read. It was like a book to them, to tell them about the sky. Now, here in Karnak, Egypt, they built it so that, again, certain times of the year, the sun would shine straight down into a building and light up something on a wall. This is thousands of years ago, when all people had to build with were stones and sticks, their hands. It's whatever they could manufacture. They didn't have optical instruments. They didn't have cameras and things to align. They didn't have lasers. And their world was very dark. There were no cities. There were no lights. In Indonesia, they built a series of temples along the path that the sun took, and this is one of them. This is in New Mexico in Chaco Canyon. Again, they built a whole city, a whole building around the alignments of where the sun moved. This is 850, 1250 AD, 1,000, 1,500 years ago. Chichen Itza in Mexico. This is an actual observatory. So this one was built specifically to observe the stars. You'd go up inside, there'd be stairs, you'd go right up in there. These windows that are up top would align towards the sun and the planets at certain times of the year. Now, as we move up in time, now this is about 1000 AD, so about 1,000 years ago. Folks were still observing the skies, but they were getting more technical. They knew things. So in this picture, this is called the Bayern Tapestry. Up here in the right-hand corner, there's a shooting thing up here. Anybody have an idea what this might be up here in this corner? Any ideas? So this is Halley's Comet. So
Hey,
Halley's
Victoria
Comet.
has an idea. Victoria, what do you think?
It looks kind of like the sun.
It does. It looks like the sun at the front of it. Okay, so this was actually Halley's Comet. This is a comet that comes around and visits every 76 years.
Nice.
So because they couldn't see it up close, because they didn't have telescopes, all they could see was with their bare eyes. But at night, the skies are so dark and Halley's Comet is so bright that they could see that the front of it was lit up like a sun. Then it had a long tail that stretched across the sky. We're going to talk about Halley's Comet later on a little bit more as well. Now this one is a sky chart, a star map. So even 1,000 years ago in China, folks were mapping the skies of what they could see. They knew that the stars were in certain places and the stars moved at night. Okay? And with their imaginations, they would look at those groups of stars, they would turn them into animals that they were familiar with. They call constellations. And they would build star maps. And that's exactly what this is. From 1,000 years ago, it is a map of the stars. So people were using astronomy for navigation as well. Okay. Let's get here. And then this man came along. Galileo de Vincenzo Bonaldi de Galilei. Everybody calls him Galileo. Now, I think probably everybody knows who Galileo is, maybe. So if you know anything about Galileo, raise your hand and tell us something that you know about Galileo. And Janet, you can control.
All right, Victoria has her hand raised. What do you know, Victoria? Then I'll come to you, Jack.
He invented the first telescope.
Well, he didn't actually invent the first telescope. What he did was make it better. So somebody else invented it. Then he came along and said, you know what? That's a really good idea. And since I'm an inventor too, I can invent one myself. And what he did is he made the telescope even better.
Jack Grippo, what do you know?
He discovered the 4 of Jupiter's moons.
Very good.
Yes,
That
yes.
is very good. So you guys are ruining all my slides that are upcoming because that's on there. That's right. He discovered the first 4 of Jupiter's moons called the Galilean moons. That's exactly right. Anybody else? You can answer
Lucas,
too.
what do you know about Galileo?
He was a famous painter.
Ooh,
I don't know about that, but he could have been an artist. I'll have to Google that
I
one.
think he is an artist.
Leonardo da
And you
Vinci.
may also be thinking of another one. So you may be
Yeah,
thinking of Da
we
Vinci.
think that's Leonardo da Vinci probably.
Yeah. Hey, all right, Maggie's got a question. All right, Maggie, what's your question, my dear?
Not a question. I know he spent a long time in jail and was put to death because he was thinking different thoughts.
Ooh, yes.
Well, that's actually he was found guilty of heresy against the church because of his thoughts. He wasn't actually put in jail so much. He was actually under like house arrest, like everybody here is. So basically, he was told you can't leave your house for the rest of your life, and he actually died there for the remainder of his life. And it was because of his thoughts and his ideas. They were so radical, so different from what the world thought at that time. So let's jump in, and you're going to see what you guys talk about.
George, I've got another thing from Karen Johnson. I'm not sure that's your name, but you've had your hand up for quite a while. What's your comment, my dear?
So it's about what the last person had said. He was accused of heresy because he thought that the Earth wasn't in the middle of the universe, but the sun was.
Fantastic.
That's exactly right. That's exactly what he was found guilty of. He was
Is your
found guilty
name
of heresy. Yeah.
Oh, hold on one second, George. Is your name Karen?
No, my name's Skylar.
Skylar, a pleasure to have you. We also have a comment for Christopher. So hold just one more second. Christopher, what's your thought?
He also discovered that the Earth is round.
No.
That was discovered actually a long time ago. In ancient Greek times, they actually did experiments using basic trigonometry, so stuff you'll learn in 8th, 9th, 10th grade. And using the angles of the shadows at 2 different places on the Earth, they were actually able to figure out, well, the shadow's this length here, it's a different length somewhere else on Earth at the same time. You take those angles and you use them. Basically, you see where those angles will intersect later on. And using that, you get like a slice out of the Earth. You can figure out, of course, how long the distance between those two cities is. They'd measured that before. And using that, they actually figured out how large the Earth was. And they figured out, well, they already knew before that it was round because that's what they based the experiment off of. But they knew how big it was to actually a pretty accurate measure for how long ago they did that. It's actually pretty close to what we've measured it today.
And Taba Sweeney from India, do you want to ask your question?
It's more of a comment that I've heard. It says that Galileo was often kept away from mathematics as a physician would earn a much higher salary at that time. And one day, after accidentally attending a geometry session, he decided he wanted to pursue mathematics as well.
Oh, fantastic. And you also had something else that he developed a thermoscope. Is that what you said?
Yeah.
All right. Let me take for any more questions here. All right, Ander, we're coming to you. Last comment, and then we're going to let George and Eric move on. Go ahead.
So this is adding on to your question. I believe they cut off his middle finger after he died, and it's displayed in a museum.
That's right. It is displayed in the Galileo Museum in Italy. That is correct. So when his body was moved later on after he died, and they took 3 of his fingers, one of them is actually on display in the museum. So if you were to
Why
go
would
to
you take a finger?
Because I don't know. They used to collect body parts, and they would display them and they would revere them. So just like religious relic, it's the same idea as having the bone of a saint on display. That's why.
Wow. All right, continue. Those were great questions, guys. We're going to save a few so we can move on down the road, but thank you for being so awesome. Continue,
All right.
friends.
So here's everything that you guys were talking about. Galileo is known as the father of observational astronomy and the father of modern science because he got away from imagining things and studying them. He used science and he used math. Okay, he did discover the 4 largest moons of Jupiter, as we said. He misidentified the rings of Saturn. He couldn't quite see them. He thought they were moons because with the telescopes that he developed, they weren't quite strong enough, but he still discovered them. And he launched the scientific revolution. Theory's emphasis on experiments, mathematical approach to science. That's what he did. He was science-based. It was all about the science and proving. That's what Galileo did for us. So he didn't invent the telescope, but he was the first one to perform observational astronomy. He was the first one to take that telescope, which was basically like you'd see a pirate using. A pirate would look through his spyglass to see further down over the horizon. What Galileo did was he turned that spyglass to the sky and he started observing the heavens. Okay, and again, he didn't invent it, but he improved upon it. And for the first time, he was able to see the face of the moon up close. And these drawings, he did these drawings in 1610. And up until then, when you looked at the moon, it was just like if you went outside tonight. You know, when the moon's way up in the sky, you can kind of cover it with your thumb. It's not that detailed. So for the first time, we were able to see the surface of another body in the solar system up close. This page of notes is from his notebook. And what you're looking at is the very first time that the moons of Jupiter were seen, and these are his notes about it. So what you see here is night after night, the moons of Jupiter changed positions around the big one in the middle, which was Jupiter. Okay, and this is what he saw with his own eyes in his notebook. So you're seeing Galileo's first notes from the first person to ever see the moons of Jupiter. Go ahead.
And right here, you actually see where he wrote it, right? Quattro stelle, 4 stars. So that right there was the actual observation of the moons of Jupiter and what he saw them as, because you can't see any detail on the moon. If you look at them through your telescope, you're not going to see what we see with our moon. You see little points of light. They look like stars, and you really have to look at it over multiple nights and see them moving before you can realize that those are moons and not just dimmer stars you didn't see before.
And that's exactly what he did. And what that meant to him, at first he thought they were stars. Then as he saw them orbiting, he went, hey, wait a minute, something's going on. Those stars are not stars, they're actually moons, and they're orbiting another planet. And that got him thinking, well, perhaps our ideas of the universe and how things work are not right, because if the Earth is the center of the universe and everything orbits around us, how can moons be orbiting around another planet? And that's exactly what he did here. So his heliocentric model of the solar system, he figured it out by looking at those moons, by looking at the phases of Venus and saying, wait a minute, we revolve around the sun versus everything revolving around us. Now, a little while after Galileo, we had Sir Isaac Newton being born. So who can tell me a couple of things they think that Sir Isaac Newton did? He's famous for one at least.
All right, Skylar, we're coming to you. What do you think? What do you know about Isaac Newton?
So I believe he was the one who had made the idea of gravity.
All right, that's a good one. We're going to clarify here in just a minute. We're going to come and get some other answers. Thank you, Skylar. That is beautiful. Victoria, what do you know about Isaac Newton?
He created the laws of motion.
Ooh, all right. I love my girl power
Wow.
here. Fantastic. All righty, let's see here. Where else we got to go? I think I saw Alex's hand raised. Alex, what do you know about Newton?
So to clarify, he discovered gravity when he was sitting under a tree and an apple fell on his head. And apparently that sparked his memory and he didn't make gravity, he discovered it.
Oh, beautiful
But that was
clarification.
the scenario.
Yep. And he went from imagining there must be something acting on that apple to go just from hanging on the tree to falling to the ground. And he began to describe that more as the acceleration due to gravity. Anybody else? Let's see. This is a good question. Your microphone's not working. Jesse says, didn't he make the first heliocentric telescope? So I'll let you guys take it over, George and Eric.
All right. So we got some good answers there. So here's what he had. He did come up with the laws of motion. For the law of gravitation, what the apple did for him, when it dropped from the tree, he observed it. And what he thought was, why does it fall down? Why doesn't it fall sideways? Why doesn't it fall up? And with that, he came up with the laws of attraction and the laws of gravity. He also developed calculus. He invented the first reflecting telescope. This is huge. So Galileo's telescope was made of glass lenses, like this. Okay, they used it to focus light down a tube. What Newton did was use mirrors to reflect light. He did it differently. This was huge. It totally changed how astronomy was done and how telescope design was. He also discovered that white light is actually comprised of all colors of the rainbow. So if you've ever held a prism in your hand, then you know what we're talking about. So here he is, there's the apple going, and he's going, I wonder why, Here's the prism, he did this. This is huge. This is what led to the science of spectroscopy, which is breaking light down and being able to use it to figure out what things are made of. Eric did a presentation on spectroscopy, and we can tell you what an alien planet is comprised of by the light that bounces off of it.
So that's when you see scientists say this planet that we discovered has an atmosphere that probably has water. They don't know that because they went there and took samples of it. They know because the light is showing certain signatures, basically their chemical signatures, and those signatures show that there's water in that atmosphere. Because of course these planets are so far away, you can't send a probe to sample every one of them. You have to find another way to do it, and that's what spectroscopy does.
You know what, guys? I have to say, Eric, that is the clearest way I've ever heard that explained. So thank you for that. Awesome.
Okay, so again, Newton's telescope design, he used mirrors. So basically a light comes in one side, bounces off some mirrors, and comes back at your eye, versus the refractor, which is the lens type. What we're going to do here, we show you refractors and reflectors. That's the two basic telescope design. So I'm curious, we're going to go over to the telescopes here in just a minute. We're going to show you guys some different telescopes. So for anybody who raised their hand who said they had a telescope, tell us really quick what kind of telescope you have. Tell me what it looks like. Is it long? Is it short? Does it have mirrors? Does it have glass? Tell us real quick what kind of telescopes you've got.
All right, Andrew, what kind of telescope do you have?
So mine's sort of like a green one that's on 3 legs, and it's a little like round. It's like a cylinder, and it's kind of short, and I believe it's made out of mirrors.
Fantastic.
Okay.
All right, I see several hands raised. No, I'm coming to you. So Skylar, what kind of telescope do you have?
I have a reflecting telescope. Mine is a very big one. And it's blue. It also has 3 legs.
Beautiful.
Okay.
All right, how about you, Christopher? What kind of telescope do you have?
Well, I actually have 2. So I have a refracting one and a reflector.
Nice.
Beautiful. All right,
Nice.
Victoria's holding hers up. So Victoria, we just saw yours. What kind do you have?
I don't know. We just got it from like the store for my birthday.
Oh, that's awesome. All right, let's see. Is it Victesia?
Oh, Victicia. Oh, that means
Victicia,
Catherine.
yeah, she's
Catherine
here.
and Lauren are there.
Hey, what kind of a telescope do you have?
It's like it like shows us stuff when he like point out the sky or something.
Oh, that's lovely. Lovely. Anybody else? Let's see. Judah, what kind of telescope do you have?
I think I have a reflector telescope.
Awesome. Awesome. All right, let me see if there's anything else. All right, I think you guys are good to move on, my dears.
Okay, so what we're going to do, and I'm going to say we're Victicia, that was Catherine. Hi. Catherine used to live here with us. So we're going to move over to the other room. So we're going to leave this one. We're going to go off on the phone over here. Okay, and we're going to show you some telescopes and tell you a little bit about them and how they work. And we'll try to keep it not too sciencey, but you'll love it. So we're going to walk over there.
And real quick before we start, something you'll notice that a lot of these astronomers, they didn't just do astronomy. The early ones, they did physics, they did mathematics, some of them did chemistry. That's because back then there weren't a bunch of different fields you could study. You couldn't go into biology and you couldn't go into a separate physics field. Usually if you were a scientist, that means you covered everything and you especially did mathematics. So some of you for Galileo might have heard about his experiment measuring how long it took for different weights to fall. And of course, Newton did a bunch of different experiments. People like Kepler, they also did that. So basically, if you were an astronomer, generally meant you were a scientist of all different fields. And that's something really interesting that we don't really have that anymore. If you're in astronomy, you're usually dedicated to astronomy. If you're a physicist, you're really dedicated to physics. But a lot of those older scientists, they made a lot of breakthroughs that we still use, like the laws of motion. The basic things that we base a lot of our research off of, we owe back to them.
Do you guys actually recommend to have a refracting telescope or reflecting telescope if you're starting out? Do you have a preference?
I'll go over that because they're good for different things. So I'll explain there's no really better one. It depends on what you're trying to do.
Perfect, thank you.
Okay, so now, okay, go ahead and mute that one. All right, here we go. Okay, mute the volume, please. So over here in the living room, we've got 4 different telescopes set up. We're going to show you guys. We've got a refractor and then a couple of reflectors, and we're going to have Eric walk you through them and tell you a little bit about how they work, and maybe they look kind of like the ones that you have at home. But he's going to tell you a little bit about them. So the big thing what you're going to notice is the size of them, the diameter of the tubes. Okay, the big thing to remember with telescopes is that the bigger the aperture, the bigger the hole that the light can go into. So here's a little tiny one compared to a big one over here. Okay, the important thing is that the bigger the aperture,
the more light gathering capability that telescope has. And the more light gathering capability it has allows you to see fainter and fainter objects way out into the universe. Okay, that's really important. You don't need a big telescope to see the moon, okay, because the moon puts off a lot of light. But what you do need to see galaxies, nebula far away, you need bigger telescopes. And I mean, we've built telescopes that are built into the side of mountains, and we're making them bigger and bigger to be able to see them. So it doesn't matter so much the magnification, what matters is your light gathering capability to see further and further stuff. Okay, Eric, what do we got first?
All right, so basically this is a basic refracting telescope. This, when people think of telescopes who don't do astronomy a lot, this is usually what they think of: a long silver tube on top of a tripod. And this was actually my first telescope that I mentioned before. So if we look in the front here, we have a lens. That's what does the light gathering. This part is just it's a hood to stop excess light coming in from the sides. That part right in there is what matters. The light in there is refracted down the end of the tube down here, where we actually have a mirror. Now this mirror doesn't work like a mirror in a refracting telescope. All this serves to do is direct the light to the eyepiece. The eyepiece is what you actually look through. I'll talk a little bit about those later. But that basically all there is to this telescope. The whole tube's hollow. It's not as if it's fully glass or anything. The real important parts are the lens, the front, and the back. I also see that there's a little telescope on the side. Do any of you have any guesses what that's for?
Anybody want to guess what that side telescope is at? Okay, Ella, what is the side telescope about? Let's see, Judah, you got to guess. What is that side little thing about?
Doesn't it help you find things that you want, like you line it up with the lines?
That's exactly what it is. It's called a finoscope. And basically what this does is it has a wider field of view and a lower magnification than the main telescope. So with the main telescope, it's typically a very narrow field of view. You can only see a little bit of the sky at a time. This lets you see more of the sky. So if you're trying to find, say, a nebula or galaxy, it works especially well for dimmer objects because you can move it around, look through the spotting scope until you get it right around the crosshairs, and then that's when you switch to the eyepiece and fine tune it, get it right in the center.
And what about this thing on the bottom? What does this do for it? What's that called? Talking to you.
Sorry, I thought you were asking the audience. Okay. Well, in this case, the tripod is just holding up the mount here. This is called an altazimuth mount. Altazimuth means altitude, up and down. So, of course, altitude, like altitude of the mountain, is how high it is. The altitude movement is up and down, and azimuth, and that's just left to right, where you start at 0 degrees and go all the way around, circle again at 60 degrees. And so this is like the most basic type of mount you can have. Side to side, up and down. And this is, again, what a lot of starter telescopes have, because you don't need a big, expensive tracking mount to get started. And actually, to get started, I really don't recommend doing that, because what GoTo does, and I'll actually get to this a little bit later, but it doesn't let you learn the sky because it automatically does it for you. So it's actually better to get started like this. Learn where everything is, learn how to find everything before you go on to tracking and finding objects automatically. Is that good? Yeah, it's definitely good for things like astrophotography, for things like longer observing sessions. But if you want to get into astronomy, this is something great to start off with. But I started off.
So I'm curious, does anybody out there have a telescope that kind of looks like this? A refractor with a glass lens up front, long tube like this. Does anybody have one of those?
Maggie, does yours telescope look like that?
Yeah.
All right. How about you? Okay, over here at the Campbell house, do you have one that looks like that, Ian?
I sure do. Mine's the same model, actually.
Oh, same model. Awesome. All right, Skylar, what does yours look similar to this?
Yeah, but mine's just a little bit smaller.
A little bit smaller. All right. Lucas, is your telescope look like this?
Nope. In fact, mine is very short.
Oh, yours is a little bit shorter. Okay, but we see it there in the
And
background.
it's from a manufacturer that sounds like a German one.
Awesome. Lucia, does yours look like this? It does? Awesome. All right, continue on, fellas.
All right, so next one up, where are we going to go from here?
We are going to go to the small reflector telescope. So this is actually my sister's telescope, and it's a great starter telescope. So if you look down the end of this one, you won't see a lens of any kind. Instead, what you're actually seeing at the end is a mirror, and that mirror is what does the light gathering. This here is also a mirror, but all that one serves to do is to reflect the light off the main mirror and into here. So here, I have a cover on there right now, but that's where you normally put the eyepiece. So not every telescope is looking through the end like this. Reflector telescopes, they have the eyepiece actually on the side, since the light, since it goes to the bottom of the tube, it needs to be able to focus, it needs to reflect back up to here and into the focuser, into the eyepiece. So this type of mount here is also an Altaz mount, but it's a special kind called a Dobsonian mount. And what it does is it swivels side to side here. And to actually move it up and down, you need to release this. Just do that. And this type of mount you'll see actually with a lot of reflectors, especially the larger ones, because it's much easier to move around and set up than a tripod would be. Tripods and the mounts that come with them tend to be very heavy and hard to move around and take up a lot of space, especially once you get to ones that have motors or computers built into them. These mounts are small.
We have a question here. Let me see if I can find, let's see, David, where are you here? Trying to find where you are, because I want you to ask this question. So David, I'm coming to you, unmuting you. What is your question, sir?
Can I use my telescope to look at the sun?
Oh, okay. So that's actually a good question. There are telescopes dedicated to looking at the sun. And then there are filters you can get. So I actually have one for my telescope. And what those are basically, they look like sheets of tinfoil, but they're specially designed to stop almost all the light coming into the telescope, because otherwise you could actually go permanently blind just from looking at it.
Yeah,
quickly.
So the quick and easy answer for everybody listening is never, ever point a telescope at the sun or binoculars or even a camera or even your eyes. Don't even stare without sunglasses, but never, ever should you point a telescope at the sun and look through it. You could permanently damage your eyes, and that is it. That would be all. Okay, when Eric's talking about the filters, you would place a filter on the front, and it would take out 99.9% of the light to allow you to look at the sun or to use a special solar telescope. But do not ever, unless you know what you're doing, you have the right safety equipment, never point a telescope, binoculars, a camera at the sun, because you can get really, really hurt.
And not only can it hurt you, it can actually damage the equipment as well, because the heat, think about all the light of the sun focused onto an area that big, that's going to damage it. That's going to cause a lot of damage to it.
Yep.
So unless you have special equipment designed just to do that, you don't want to do that. And just finishing up what I was saying about this type of telescope, this is also good, like I said, for observing things like the moon, the planets. It doesn't have a very large aperture, so aperture is the size of the mirror lens, but it works great. I used it last night. It's my sister's telescope. Just observe the moon real quick, and it's very good at that. But now we're going to move on to a slightly larger telescope. And I actually have two of these sizes. So these are both reflecting telescopes. The thing you'll notice about this one, it has go to. So what this allows you to do is basically you punch in the object you want to go to, and it will swivel there automatically for you, and then it'll track it. So this is...
Now, do you use coordinates, or do you actually use a name of something when you're putting it into the go-to?
It really depends on the telescope. Most you just put in the name of it and it'll know, but you do have to calibrate it usually, so that'll make you like set it up to find a star, find another star, find a third star sometimes, and using that, we'll know where all the objects are. But usually, yeah, it's by name or by catalog number. When you're looking at things, what's called the Messier catalog, that has a bunch of objects logged in, or the Ring Nebula, things, the easy objects to observe. There are a lot on that catalog, and a lot of two telescopes will have that. So basically, you type M and then the number 1 through 110, and it'll go there automatically for you. But yeah, it really just depends on the type of telescope, exactly what you have to do to set it up. And we'll go over that once we get to the big telescope, because it has a special kind of go-to. But basically, this go-to system, it lets you find and track the object. So the good thing about tracking is, of course, the Earth rotates. So if you just point to an object and keep the telescope there, soon enough, the object will go out of the field of view of the eyepiece. You'll look at it, you come back 2 minutes later, and it's gone. So the nice thing about having it follow it is that you can do longer observations. You can keep your eye to the eyepiece. You don't have to constantly move it. And that's good, of course, for taking photos, because you don't want something moving out of your eyepiece if you're taking a photo. Going over the telescope itself, this is a 4.5-inch reflector telescope. So we have the mirror at the end again, and the mirror right here, the secondary mirror. And you'll notice that this one it's quite a bit larger than the other reflectors. So what do you think having that larger mirror does for us, and how much of a difference do you think it makes? I mean, it only went up, what, maybe 1.5 inches from the other one? But how much of a difference do you think that would make to what you can see?
Anybody got any good guesses about how much difference that can make? Anybody? I think you're going to have to enlighten us there. Oh, hold on. Judith's got it. Judah, what do you think?
A lot.
Yeah, it's a lot.
Good answer. Good safe answer.
Yeah. So, yeah, that's actually what I was going to talk about. With just a small increase in the diameter of the telescope, because the mirror increases by so much area, you can gather a lot more light. So, like I said before, that smaller telescope, I used it last night to look at the moon. You can look at some planets with that. This size telescope is actually what I started using to look at galaxies, to look at nebula, to look at what I call deep sky objects, things outside of our solar system. So that's what larger telescopes are good for. Let's move over to this one now. And you'll see this one has a longer tube. It's the same size. It's the same size mirror though. But the thing you notice about this one especially that's different, besides the size of the tube maybe, is the mount. So do any of you want to take a guess as to what this whole device here is for, what it does? You'll notice there's this little knob, move it side to side. And this one as well. And that's unlike our other past two that we looked at, where you just grab it and move it side to side. What do you think that does for us?
Skylar, you've got your hand raised. What do you think it does?
So that's actually the telescope that I have. It's very close to it. And I think so you can move the telescope around with it, like left to right and up and down.
Yep. So these are what are called slow motion controls. Of course, that's because they move it very slowly. You can do very fine movements with these, or you can do coarser adjustments to find something on the other side of the sky. But this mount, called a German equatorial mount, and this is the kind that you'll see a lot of people who do astrophotography using, because what you can do with this kind of mount is align it with the north celestial pole. So that's, if you were to take a line from the north pole of the Earth and go up into the sky, straight up, that's where the north celestial pole would be. And some of you might know that's near Polaris for us in the northern hemisphere. Southern hemisphere, unfortunately, they don't really have a bright pole. It's still nearby, but there really isn't one. So you kind of have to just judge off of the nearby stars. But what aligning it with that lets you do is your telescope, it'll let you track it in one direction across the sky. It'll let you track objects because of the way the Earth is rotating. And that's good, again, because your objects will move out of the field of view with the Earth's rotation. You can recenter them much easier, and you can have a camera hooked up to the telescope to take a photo of it. I'll briefly go over astrophotography later, not much so. And this is the kind that you'll see a lot of motors hooked up to, because you only need it really to go in one direction at a time. And now we're going to.
Well, how come on this one? So on this one over here, I noticed that the tripod is made of metal, looks like aluminum and plastic. And this one is also aluminum. This one doesn't have a tripod at all. This one's made of wood. How come? Why is that?
If you look at those two, those are decently light mats. Those are decently light. This is actually really heavy. This is solid metal up here. And if you have a weight down here as well. This weight is to keep the telescope from tipping over. It's called a counterweight. And so you need a really sturdy tripod to keep this up. So yeah, these kinds of tripods will typically be made of solid wood or metal, like sturdier metal. You won't typically find these in plastic or hollow aluminum because it just can't support the weight of this, plus the telescope, especially if you get to larger telescopes, so 6 or 8 inch telescopes, like double the size of this. A plastic mount wouldn't be able to support that kind of weight. It wouldn't hold it. And you need a stable mount. That's an important thing, because without that, your image is going to be all shaky because it moves so easily. Like the slightest gust of wind will move your whole image. And remember, since you're looking at something magnified, that movement is magnified as well. It's very important that you keep it stable, you keep it sturdy, and that it can't move around freely as you're observing.
Okay, so before we move on to the big one, I'm curious, does anybody out there, I know at least one person does anybody out there have a telescope like this one or like this one with the motor controls? Does anybody have one of those?
Ander, do you have one?
Yeah, I have one that sort of looks like the one with the motor controls, except it doesn't have motor controls.
Ah, gotcha. Anybody else? They have one that looks like this. Oh, Christopher. Yeah. Does yours look like either one of these?
Mine looks like the one with motor controls.
Oh, it does. Fantastic. All right, Skylar, what does yours look like?
Mine looks like the one with the not the one with the motor, but the other one with the controls. Mine is just it actually looks exactly like that, except for mine is green.
Awesome. Awesome. All right, guys, continue on.
Okay, we are going to move on. So this is the big one. We're going to talk about this one. So the other ones were very small, a 2 inch and a 4 inch, or 3 inch and a 4, sorry, 4.5, Eric says. This one is a 10-inch aperture reflector telescope, and Eric's going to tell you about that one.
That means we actually have a mirror down here. If you look at that mirror is 10 inches across, right back there. And so what that does, of course, is think about how big of a change it was from 3 inch to 4.5 inch. Now imagine 4.5 inch to 10 inch. That's a huge change. See how much bigger it is. So this is the telescope that I usually use. And this is great for doing what's called deep sky observing. So dimmer objects, things like galaxies, things like nebulae. And it works very well for that purpose. And you can observe planets with
we've got just a bit of glitch for a second. Continue on. We had just a minute of glitch. You might want to rewind what you were saying just by a couple of seconds.
All right, okay. So basically I was saying this type of telescope is very good for what's called deep sky observing. So things like galaxies, nebulae, dimmer objects that you might not be able to see with these smaller telescopes. That's because those objects are so dim, you need to gather a lot of their light to be able to see them. Now, if you go to a really remote location, you might actually be able to see the Andromeda Galaxy with your eye. But if you want to get it through a telescope, you're going to need a larger size, probably, especially for any of you who live in larger cities like we do. You can't see that with the eye. You can't see them through everything with the eye either, the band of it at least. So you need to be able to magnify that light somehow. And that's what this does for us. So this is also a reflecting telescope. It might look maybe more complicated than that one, but it's really just the size up. It's a hollow tube inside, mirror at the end, and a mirror at the front. This is also a Dobsonian mount. And why you usually see this kind of mount on larger telescopes is because it's much easier to transform than a German equatorial mount would be. This is just wood, and it comes apart very easily. You just screw these off, pick up the telescope tube, and transport it as two different parts. Really, the weight is down here in the mirror. Aluminum, of course, it's not that heavy. It's a hollow tube of aluminum. So what you really need to be careful of is the mirror at the end and the base itself. Those are really the only two parts that weigh much. So the good thing about reflecting telescopes, especially refracting telescopes, in order to make large lenses, they're both very heavy and very expensive to move. So that's why you see a lot of larger telescopes there. They have mirrors. They don't have lenses because those lenses are so hard to make accurately. One thing that we don't have here is it's called a Schmidt-Cassegrain. It's basically a mix between the two. So you have a mirror at the end, a lens at the front, and then a second mirror right in the middle. And so those are typically, if you've seen telescopes that are like very short tubes, they might have this diameter, but they might only be maybe a foot long, maybe even shorter. And those are good they're like a mix between the two, like I said, and they're good for all kinds of observing. Why I said that this is better for deep skies, because of course you can gather more light. Refractors, they don't have an obstruction in the middle. So with the reflector here, you see we have this. The secondary mirror, it doesn't do much, but it blocks some of the light coming in. And for objects like planets, that can actually make the image less clear because of how bright they can be. Versus if we look into the front of the refractor, you'll actually see it's just a lens. There's nothing blocking the view. So a lot of people who do planetary observing or lunar observing, they'll use larger refractors, but of course not that big. I've never seen a refractor of this size, but I've seen lots of reflectors like this because of how easy they are to transport. And a lot of people, when they think of astronomy, they're going to think of telescopes, and you need a telescope to get into observing. Well, that's not really true at all. And a great way you can get into observing is binoculars. So there are normal binoculars you can buy at the store, and I actually have a pair, and I used a pair of just normal small binoculars that you could buy pretty much anywhere to see Jupiter, to see its moons, to see the moon itself and all the craters. So you can do a lot with just a normal pair of binoculars for $20 or $30. Then there are dedicated astronomy binoculars like these, or even bird watching binoculars, things like those that work well. And these are essentially two mini telescopes. They're two refracting telescopes mounted next to each other. And you'll see with larger ones, they'll often be mounted just like a telescope is, because you don't want to be holding something of this weight while you're observing, because of course your hands are going to shake. And like I said before, magnified image, magnified shaking, it's going to move around a lot. But for those of you who are interested in getting started in astronomy, something like this works wonderfully. If you don't have the space for a telescope, if you don't think you have the time to learn how to use a telescope, this is a wonderful way to get started in astronomy, and maybe to segue you to your first telescope later on.
So the one thing we haven't talked about the telescopes yet, so we talked about light gathering capability, and that's the size, the aperture that lets light go down the tube, bounce off the mirror, come back up to your eye. But there's an important part to get from that bouncing off the mirror to your eye, and that is the eyepiece. So Eric's going to tell you a little bit about eyepieces and what they do.
So eyepieces are what actually let you see things. Because if you take this out and you try to look at an object, what you're going to see is a reflection of the mirror and your eye. That's all you're going to see. You actually need the eyepiece in here to be able to focus the image, and this is what determines how much an image is magnified. A lot of people, when they get into astronomy, they believe that the higher the magnification, the better the image. That's not true at all. It's usually the opposite. My most commonly used eyepiece is my second lowest magnification eyepiece. And that's because with those eyepieces, with lower magnification, you typically get wider fields of view. So that's this one. You get a wider field of view. It's not as, what's the word for it? It's not, it wouldn't be as dim. Because actually, as it's the higher the magnification, the dimmer the image. So if you try to look at dim objects like a nebula under high magnification, the light is so scattered that you can't really see anything. You need to be able to get the bigger image to be able to actually see the object. Now, of course, there are things that high power is good for. So observing planets, if you want to see the details, if you want to try to see the Cassini division, Saturn's rings. Yeah, high power is good for that. But too high of power on any telescope will ruin the image. It'll make it so you can't really see any details. And that's where you want to make sure you have good eyepieces that you can see good detail with. And because magnification, a lot of the time, doesn't really matter. I use a 25 millimeter eyepiece on this, on that, on pretty much everything that I observe with. And just real quick, the 25 millimeter, that's a measure of the eyepiece itself. And the lower this number here, the higher the magnification. So a 7 millimeter is much higher magnification than a 25 millimeter. And there's actually a formula for determining how high that is, but basically my most used ones are 25 and 10, low power, high power. And that's really all you need to get started with observing. You just need two good ones to switch between.
Hey, Eric, there's a question from Jesse. Would it be more eye straining to use a less magnified lens? But it sounds like what you're saying is no, the opposite of that is true.
Yeah, it's definitely more straining to use a higher magnification lens. And actually, if you look at it, see how small this is right there compared to this. So it's a lot more strain on your eye. There's less eye relief, which means you have to put your eye much closer to the lens to be able to see than you would with a lower magnification eyepiece. And then there are some like this. So this is actually a 2-inch eyepiece down here, and this is usually only used on larger telescopes. A lot of smaller ones can't take this kind of eyepiece because they don't have the adapter for it, and it's a very heavy eyepiece. So lighter telescopes, this might actually tip it, so you can't really observe. But this is great for if you're looking at very, very large objects. So if you're looking at large galaxies or at clusters of galaxies that need a wide field of view, that's what this is for. But yeah, typically the higher magnification, the more the eye strain and the less clear the image.
Okay, so that is what we've got about telescopes. So what questions do we have? Do we have any more questions about telescopes themselves, about mirrors, about refractors, reflectors, about eyepieces, about binoculars, before we move back over and take you on a tour of the solar system?
All right, let me do a round robin. Raise your hand just like this if you've got a question for me or, all right. So Lucas, what is your question, sir?
My question is the 2-inch eyepiece good for looking at Jupiter?
No, because for planets, you want a higher magnification because that way you can actually see details on them. So this eyepiece is good for looking at galaxies, like I said. So there are 2 galaxies. They're called M81, M82 in the Big Dipper. And what you can use this for is getting both galaxies in one eyepiece, which is actually really cool. You're looking at 2 galaxies, 2 huge amounts of stars with one eye. And so that's what this is good for. But no, for planets, you want to use something more like this, where you can see more detail on the planet's surface. What you just want to be careful of is going too high power for your telescope. The larger the telescope, the higher the magnification you can get with a clear image. If you go too high power, it gets very blurry very quickly.
Okay.
This is such great information. One more question. Jesse wants to know, can you put a fisheye lens on a telescope? Have you ever done that?
Fisheye, well, no, I don't think you really can. The closest you get to a fisheye is just a very wide field eyepiece, something like this. So like I said before, you're looking at a very narrow region of sky with this, so you can't really get that wide of a field of view. You get a couple of degrees at most, depending on the telescope you're using.
Yeah.
So no, there really isn't a fisheye lens eyepiece, but there are ultra wide field eyepieces, which those are typically the 2-inch ones, or at least the very low magnification 1 1/4 inch ones. And that's the closest you can really get to that.
Okay.
Awesome. You are so knowledgeable about telescopes. It's like, I want to download your brain, Eric. This is great stuff. All right. So, and last thing, again, do you have a brand of telescope that you would recommend for anybody starting out? I know Celestron is a great brand. Any others out there that you guys recommend for a first telescope?
Well, I don't know that the brand really matters very much, to be quite honest.
Three big brands right here. So we have an Orion right here,
The big ones.
Celestron right here, and a Meade right here.
Yep.
So those are the three big ones, and they all have great starter lines. This was the one that.
Yep.
This was my second telescope. I bought it with my own money after we moved here at an astronomy convention. It was used for around $70, and it works great. This is really all you need to get started with. And something I want to mention real quick is you really don't want to get this as your first telescope.
No.
It's too big for someone who doesn't know the skies well. It's first, it might be too heavy for a lot of younger people to carry by themselves. Even though it's not that heavy, it's difficult to set. It can be difficult to set up, and especially if you don't know the skies, this is too high of a power to be able to really tell what you're looking at. And
Yeah. So what we always tell folks, we always tell everybody, do not just go out and buy a telescope because what happens is the kids will get bored. They'll take it outside, not know how to use it, not know what they're looking at, and get bored really quick. So if you're going to get a telescope for a kid to start with, the important thing is to get them involved in some kind of an astronomy class or an astronomy club so that they can learn how to use it, learn what to look at the skies. That's the important part. These telescopes here, the black Celestron was like $75 used. You know, the silver one over here, the refractor, you can pick that up at a toy store. These are $79 or something like that. They're easy and they're cheap. And a lot of time kids will get them from grandma, grandpa, mom, and dad for Christmas and for birthday presents. And then they use them once or twice to get so bored because they don't know what to do with them. They don't know how to use them. That's the important part. Get them involved so that they learn astronomy, learn how to use the scopes. You know, don't go out and spend $1,000 on a telescope. It's a waste of time. You can pick one up at a yard sale because that's what the other kids' moms did, and now they're selling them cheap. So that's the advice: is don't rush out to get a telescope. Learn astronomy first.
I think the perfect starter size is 3 to 4.5 inch. You don't want to go too small because then you might get discouraged because I can't see anything with this. I can't even see Jupiter clearly.
Yeah.
So what's the point? But
or even one of these, or like Eric said, a set of binoculars. That's really all you need to get started. The important part is learning the skies.
Yeah.
That's the important part.
So after your first, you might step up to 6 or 8 inch. And that's good for people who are really dedicated and want to do more observing. But yeah, definitely start with something like this or like the black one that you see over there.
Okay. So Janet, how much time do we have left? I'm not looking at the clock.
Right, so we've got about 15 more minutes. So show us some cool space stuff now that we've learned about astronomy, the people who are kind of the fathers and architects of this whole study of the sky and your great telescope. So show us some cool space stuff.
Okay, what I'm going to do, I'm going to take you. Okay, you know what? Let's do this. I've got a tour of the solar system, or we can do actual space stuff. What do you want? Which one? I can do the slides with the planets or stuff first, and then we can fill a little space at the end.
I think stuff. I think I want to see some cool space stuff.
You want stuff? Okay, we can do stuff. So we'll start over here. So there's various ways for kids to get involved in space. Okay, one of them, of course, is models. Everybody loves models, and they can be very detailed. They can be very plain. You can make them yourself. You can buy them bought. Okay, so this one in particular is a model of the Space Shuttle Discovery. And this one is really cool because it's a partial see-through. You can see how the wings were built, the tail, you can see the engines inside. You can see the little astronaut up there floating around. You can see into the cockpit. And this thing's almost 2 feet long. It is huge, but it is cool. And it gives a really good idea of if you were to hold a space shuttle in your hand, what it would actually, no kidding, look like. So models are a great idea for getting kids involved. We've got the space shuttle. So we've got, of course, Apollo 11. We've got the lunar lander. Okay, and of course, you can't have space without your Saturn V. Okay, when I was a kid, I had one of these. It was almost 3 feet tall. It was crazy. Here, now this is kind of special. Eric, could you pop that open?
Yep.
This jacket is, of course, your standard NASA jacket, and it's kid size. And the cool thing about it is that this jacket actually belonged to Buzz Aldrin. We got this when Buzz Aldrin had kind of an auction, and we got this at auction. So this jacket actually belonged to Buzz Aldrin. So you can collect models, you can collect things by scientists, by astronauts, by scientists, different folks. Okay, we'll walk over here. Let's see. We'll stick with Buzz Aldrin for the moment. Okay, so this one you could do books. Okay, this one is written by Buzz, and this one is signed by Buzz.
That is so super cool. I do know after talking with Buzz that he really loves this story. So if anybody's out there wants to make a note of a book to order, Encounter with Tiber, you would really like it.
Yes, indeed. Okay, so let me go. I'm going to show you. So I'm going to show you what got me into space real quick. See this book here? When I was a kid, this was my favorite book. And the reason it was my favorite book is because it had pop-ups.
Awesome.
And I loved it. And I used to sit there as a kid and sit here and move all the little things and watch everything pop up. And I would play with it. I remember playing with it for hours. Little 3D pop-up. And this is from 1969. So easy things like books can really get a kid interested, and they're easy to collect and they're fun to collect. Another one I had as a kid was this beat up ripped one. You can tell it's beat up because I read it so much. And again, this is early on in the space program. Okay, and this is Astronaut Cooper up on the cover. And the cool thing about it is that these many, many, many years later, I was able to get this, which is the same cover photo signed by Gordon Cooper. So there's one of my, oh yeah, I know. I mean, that was like, I was so happy with that because that's my memory as a kid is that book. It was fantastic. There's some other cool things that you can have out there, some other stuff that's out there. We'll bring this in real quick. So this is down in the corner here is a little tiny piece. Where is it? I can't see it right there. That little piece is a piece of Kapton foil from the Apollo 11. Okay, and things like this are not super expensive. You don't have to go out and spend thousands of dollars on things. They can be fairly cheap. Crew photos. Of course, this is the crew photo of the Challenger. We have this one. If you want to get other crew photos or just astronaut photos, there are a lot of astronauts that come, which we've got all of these here at the Space Foundation locally. So the astronauts will come and visit. They are more than happy to sign their pictures. This one's, yeah, that one's to Eric. Okay, this is Leroy Chow. We say that Leroy Chow, Dr. Chow, is our astronaut because it seems every time we go somewhere, he's there. We've seen him live 3 or 4 or 5 times. We went to Houston to the Space Center. He was the guest speaker. We got there and there he was up on the stage. We had no idea. Okay, there's astronaut Brian Duffy.
I've met Brian. You know, we should compare because I've got an autographed copy of Jerry Ross. I've got Charlie Walker. I wonder if we could, there's Linda Godwin. I've got Hoot Gibson's around. So yeah, I collect astronaut autographs as well.
Yep, there's Nicole. Yep, Nicole Stott. There she is.
Awesome.
Yep, so we did that. What else we got? Eric, could you grab the patch over there? So the patch is really cool. So this one you're going to see. So this one is cool for a special reason. So this is Apollo 9. Okay. Now this one is cool because this patch actually belonged to Neil Armstrong. This is his patch. It was from his personal collection. And we picked this up. I would have loved to have an Apollo 11 patch, but you know what? I couldn't afford it. They were too expensive. But an Apollo 9 patch that belonged to Neil Armstrong, still his, I could afford that. So things like this to collect are super cool. How about that, Eric? Let's pick that up real quick. So this is pretty cool. Okay, this is a shuttle era technician's set of coveralls. This is what the technicians would wear when working on the spacecraft in the area. Flip it around. Full-fledged NASA thing. It's got the meatball there. It's got the pocket for holding checklists, and of course you got to have the flag on the side. And again, this is something, you know, I'm a little bit too big for this now, but this fits Eric. He could wear it. He could wear it for Halloween if he wanted to. And when we go out and we do outreach, I usually wear this when I go out and do outreach. It's a little bit too short for me, but I wear it anyway. And I have to tell the kids I'm really not an astronaut, because when I come in with this and all my stuff, everybody thinks I work for NASA, and I really don't.
Oh, I love all this stuff. It's so great. It looks like Jesse's got a Saturn V plushie. Hashim collects pins. I bet there are other collectors out there of good space stuff. What is this?
So this is cool stuff. Okay, this here. Okay, let's see how close we're going to be able to get here for focus wise. Okay, well, that's a piece of the moon. This is a lunar meteorite. That is a piece of lunar breccia. So what happens? How do we get this? Because we know that, of course, you know, we can't just go out and buy moon rocks on eBay or anything like that. Okay, but we have lots of meteorites on Earth that have come from all over the solar system. And what's happened is, you know, there have been collisions in space. A meteor's come in and is smashed into the surface of the moon. It has ejected parts of the moon into space. Those have been sucked in by Earth's gravity well. Then they've been found. So this is an actual piece of the moon, and we know that because we can do chemical analysis of it or spectroscopy, measure its light waves, and we know that it is a piece of the moon. Okay, and right next to it, just as cool, okay, that is a piece of Mars. This is a Martian meteorite. Okay, now we all know that Mars is red. Now this one has kind of a reddish tone to it, but really that's just from people handling it over time. But same thing, this is an actual piece of Mars that you can hold in your hand. Okay, next to that.
That is so super cool.
This.
And what is
that? Okay, this one, way out there in the asteroid belt, there's two really big bodies. One is called Ceres, one is called Vesta. Ceres is the biggest body out there at about 950 kilometers wide, and Vesta's next. And this is a piece of Vesta. So there have been a lot of Vesta meteorites found. And the theory is, a long time ago, Vesta took a big hit. It almost shattered completely. And that resulted in a lot of its body going out into space. And we have sent spacecraft to Vesta, have orbited it. I think it was the Dawn mission, I think it was. I don't remember exactly. So we know exactly what it's made of. We know its exact chemical composition. We have some really good close-up video and pictures. And we know that this is a no kidding piece of the asteroid belt. So right here on my dining room table, we have a piece of the moon, a piece of Mars, and a piece of the asteroid belt.
So super cool. Can we get the both of you back on camera? You may just want to, I don't know if you want to hold your iPhone in front of you both. Any last questions as we wrap up? We might have to have you back to talk about the solar system, but as I scroll through here, anybody have questions for George and Eric this morning? Do you have your hand raised, Evie? No, okay, you're just stretching. All right, let me come through here. Any questions for our okay, let's see. I got you, Lucas. What is your question, hon?
I had a question and something I want to say.
Sure.
And the first thing I want to say is I have a stuffed animal that's supposed to look like Saturn V, and
okay.
And my second thing is that for some reason where I live, it has been too dark to see the moon and the stars recently.
Yeah, it's been very stormy where you live recently, indeed. Any other questions or comments? Let's see here. Let me make sure I've made my rounds. Well, guys, I think as we come to a close of our broadcast here, do you guys have any last things that you want to say to these students who are going, wow, I really wish I had a telescope and now I'm more interested in astronomy, and wow, I want to maybe collect some cool space stuff. Any last things that maybe even Eric, you would say, because you've been doing this since you were 4, any last things you want to tell the kids about following their interest or their passions?
Yes, so unlike what a lot of people think, you don't need a bunch of expensive equipment to get into astronomy. You can get started with, like I said, a pair of binoculars or a small telescope. The really important thing is to learn the sky, learn your observing style. There are different observing styles. Some people, like me mostly, I just observe for fun. I go outside every night, not every night, but whenever I can, to observe for fun. Some people do it scientifically. So there are people who they have whole setups dedicated to finding comets or asteroids and reporting them. There are some people who do astrophotography, and they have their telescopes set up to take photos of the night sky. So of course, those kind of things, they need some more dedication. They need more experience, but anyone can get started in any kind of observing, and they can do pretty much any. You can start tonight if you wanted to. You could go out and observe the moon. You could go out and observe the stars, try to find some constellations. Constellations, learning them are a great way to get into learning the sky and finding objects.
And the other thing is again, get involved with your local astronomy club if you can. Okay, here in Colorado Springs, we're the Colorado Springs Astronomical Society, csastro.org. You can Google any of these. Talk to your science communicators, like Janet here at Janet's Planet, Explore Mars, Rod Sparkman at StardomSpace.com, the Space Foundation, or even go out on NASA.gov. Go to your library. Go online, study and learn. You got to be interested. You got to study and you got to learn. That's all it takes, is to find something you like. If you like the Saturn V, study the Saturn V. Learn how it flew. Learn the engineering portion of it. If you like telescopes, you wonder how they're built. Maybe you want to build your own. Learn how they're built. Learn how to grind a lens. You can do all these things yourself. The important part is to ask the questions and be involved, and don't be afraid. And ask your mom and dad to help you, because they'll love to do it. And when you're out there at midnight watching the moon, they're going to be out there with you anyway. So get them involved. And it's a lot of fun. It can be a lot of fun. It can be a lifetime of learning just by getting interested in one little thing and just taking the steps to go out there and do it.
That is all great advice. One last question. Ian, I have unmuted you. What is your question, my dear? Ian?
What is your favorite telescope?
What is your favorite telescope? He's calling all the
What
way
is your
from
favorite telescope?
Yeah, of the ones that I have, it's definitely my 10-inch, because I just love being able to do a deep dive observing. That's what I enjoy doing. So looking at things like nebula and galaxies, I love doing that. And that's what this telescope is great at. I use it when I observe mainly just this one. And so that's why I like this telescope. But of course, before that, I used this one, and I could do a bunch of the same stuff with this one as I could with my 4.5.
My favorite telescope is the Hubble, until the Webb is up there. Once the Webb is up, I think the Webb is going to be my favorite telescope. For now, it's the Hubble. But for here at home, it's whatever one we happen to be using. But this one's the best. This 10-inch is the best.
Well, guys, I am about to unmute everybody so we can say thank you. This was a brilliant, brilliant session. I hope you guys maybe got a little more interested. And what I heard both of these guys say is, if you're interested, learn more about it. And again, start small and learn your night sky. Because again, we can't just go from like the biggest telescope and understand what we're even looking at. All right, you guys, you were fantastic. I'm going to mute everybody.
Thank you.
I have a comment.
Thank you.
Thank you.
Thank you.
All right, guys, it's like we have had a great morning. Let your mind revolve around this thought. The universe is always expanding. Let your mind do the same. And that's the view from Janet's Planet. Thank you guys so much. Have a great morning. We appreciate it so much, you joining us. Bye, everybody. link that you write.